Okay, 7-2, powers of 10 and scientific notation, more review from 7th grade, and you should have Know It Note page 95, and it does turn over to page 96 there for this lesson. So here we've got some powers of 10. You've probably seen this chart in math. You've seen it in science when you've talked about scientific notation there. And you can see how when you divide by 10, the powers go down and the number of zeros gets to be one less, but it's actually better to think of it as the decimal moving to the left every time, so that every time the number gets smaller, we're moving the decimal one place to the left. And when we multiply by power of 10, right, it's going the other way. Okay, so there's nothing you need to write down quite yet. Just taking a look here at this. I think the next one talks about multiplying by 10. It's the same chart, right? But the exponent increases each time by 1, and the decimal point moves one place to the right. So the numbers are getting bigger and bigger and bigger, right? Move that decimal place to the right and fill it in with a placeholder 0. This goes in the chart there in the middle of the page. So when you have a positive integer exponent, when you're calculating those powers of 10, you write down a 1, and then you count that many places, the number that the exponent says, to the right, and fill in any placeholder zeros. And you've got a spot for an example there. 10 to the third equals 10,000. It's a 1 with 3 zeros after it. If we had 10 to the 8th, it's not 10 with 8 zeros, it's a 1 with 8 zeros, or a 1 where you then move the decimal 8 times. Right, so 1, 2, 3, 4, 5, 6, 7, 8, and then go back and fill in the commas so that somebody can read your number. So 10 to the 8th power is 100 million. For a negative integer exponent, this is the next box down, you're still going to write down a 1, but now you take that exponent number and you count back that many places from the right side of the number, the right side of the 1, and you put the decimal there. Fill in any placeholder zeros. So remember, 1 is really 1 point something. So when we're going back now, we start on the right side and then we count backwards from there. So 10 to the 6th, we started here. 1, 2, 3, 4, 5, 6 places, which means it's 5 zeros. Let's write down one more example for your notes. How about 10 to the negative 4th? So we start with a 1. We go back 4 places. 1, 2, 3, 4. So some of you might be catching on that it's 1 less 0 than the exponent number is. Okay. So let's do a couple more examples really quickly. You can just jot these either in the boxes there where they would go, or just off to the right. Shouldn't take very much space, or above the box. Any of those places will do. Give them a try yourself. Pause the video and try them. Now here's the answers. We're going to count back 5 places from the right side of the 1. So that's going to be 4 zeros after the decimal, then your 1. I think that's 1/100,000th. 10 to the 4th, it's a 1. Move the decimal 4 places, 4 zeros, you get 10,000. 10 to the 9th, it's a 1 with 9 decimal places moved after that. So 9 zeros filled in, which is 1 billion, right? Ones, thousands, millions, billions. How about the other way? Right? 1 million, right? The decimal's over here, right? Which is 6 places away from the 1. So we would say that's 10 to the 6th power, right? Here we've got 10. It's always 10. And the decimal is 1, 2, 3, 4 places back. So 10 to the negative 4th. And 1,000 would be 10 with 3 zeros. So 10 to the 3rd power. Should be able to go back and forth and back on these. Okay, next bit of your chart. We can find the product of any number in a power of 10 just by moving the decimal point. So instead of starting with 1, the way we did on the previous ones, now you're just going to start with whatever the number is, move the decimal from wherever it is. So on the first part of that blank chart below multiplying powers of 10, you're going to fill in if the exponent is a positive integer, move the decimal point to the right. And they give you an example, 125 times 10 to the 5th. Here's the decimal at the far right end of the number, and then you move it 5 places. Go back and fill in your commas. If the exponent is a negative integer, then the decimal goes to the left. All right, so here in our example we have 36.2, and so we're going to take it from where it is, and we're going to move it back 3 places. Easy cheesy, right? Doesn't this feel so much better than chapter 6? Okay, so this is not scientific notation yet, because scientific notation, the numbers have to be in a very specific format, and these aren't, but we can still multiply them. Go ahead and pause the video, move the decimal, count it out. Now that you're back and you've tried these on your own, squishing them in there at the bottom of page 95, or turning the page over, doing it on page 96, because you've got plenty of space over there, we're just going to take that decimal and we're going to move it 8 places. So the first 2 places would be around the 8 and the 9. So now I've accounted for 2 of the 8, so I need 6 zeros. A little arithmetic in my head makes life easier. I don't have to draw all those little jumps. So that would be 2,389,000,000. 467 times 10 to the negative third. Well, here's the decimal hiding after the 7, and I got to go back 3 places. 1, 2, 3. So I end up with 0.467. Okay. Now, finally, on to scientific notation. There's not really a spot to write how to do scientific notation. So if you don't remember this part, definitely jot it down there below their little graphic. Scientific notation, we know, is for writing very large or very small numbers. And scientific notation always has 2 parts. It has the power of 10 part, that's easy. And then the first part has to be a number that's greater than or equal to 1 and less than or equal to 10. So if we thought about that as a compound inequality, it would look like this. X has to be greater than or equal to 1, but less than 10. Meaning it only gets 1 place to the left of the decimal. Okay? No multiple digits to the left of the decimal. Just a ones place, then the decimal, and you can have as many places after the decimal point as you want. You did this last year, so it should be review. We're going to do a couple problems here in just a second. Remember that standard form, that's the way we usually write numbers. Scientific notation, that's what we're talking about changing it into. So this says that Saturn has a diameter of about 1.2 times 10 to the 5th kilometers. Its distance from the Sun is about 1,427,000,000 kilometers. And we're going to write the diameter in standard form. So right there on page 96, go ahead and jot it down and give it a try. You're going to move that decimal 5 places. So the first place is around the 2. And then you need to move it 4 more places that get filled in with placeholder zeros, which tells us that Saturn's diameter is approximately 120,000 kilometers. Now we're going to do the other half of the problem, which is about its distance from the Sun, and we're going to write that into scientific notation. So we take the non-zero part of the number. I didn't go through this before, so this, if you haven't done this in a while, listen carefully. We take the non-zero part of the number and we turn it into a number between 1 and 10, right? Greater than or equal to 1, less than or equal, less than 10. So that would be 1.427, right? Because 14 is too big, 142 is too big. And then we imagine, all right, so if I put the decimal there, how many places would I have to move it to get all the way back out to where my decimal really is? And we'd have to move it 3, 6, 9 times. Now the way that I remember whether it's going to be a positive exponent or a negative exponent is I just look at the original number. Is it a really big number? It's going to be a positive exponent. If it's a really tiny number, then it's going to be a negative exponent. Rather than trying to remember, oh, left, right, this, that, right? I just do it by logic. If I'm trying to make the number tiny, it's a negative exponent. If I'm trying to make the number big, then it's a positive exponent. Okay. So here we've got another exciting example. 143,000 kilometers. Write that in scientific notation for me. And here's what you should have. 1.43, because we have to turn the non-zero part into a number between 1 and 10. And then if the decimal is there between the 1 and the 4, then I'd have to move it 5 places to get it back to the far end of the number. And it's a big number, so it has a positive exponent. And we could label it to kilometers. Okay, almost done. Okay. Last little bit here. Ordering numbers from least to greatest when they're in scientific notation. Now, you could, of course, take them all out of scientific notation and then put them in order and then rewrite the answer back in scientific notation, but that seems like kind of a pain. So instead, we're just going to leave them in scientific notation. The powers of 10 really tell you in general how big a number is. So the first step is just to put them in order by powers of 10. We're looking for the smallest number first, and so the smallest number is the biggest negative number. So in this list, the biggest negative number is 5.4 times 10 to the negative third. That's the tiniest number. The next smallest numbers both have powers of -2. Okay? So that's when we get to step 2. Right? Then you just order them in the same way you would order any numbers based on the front part. So which is smaller, 1 or 1.3? 1. So that's going to be smaller even when it's written in standard form, right? Even in scientific notation. So there's our next one. Then we have 1.3 times 10 to the negative second. Now we're looking for the next smallest exponent, and it looks like it's +3. So 6.3 times 10 to the third. And then we have two things with 10 to the 6th power. 2.1 is smaller, so 2.1 times 10 to the 6th. And last we have 4.1 times 10 to the 6th. And that's how we put them in order. First you look at the powers of 10, then you look at the front numbers to get them finished up. And you can go ahead and try this one on your own real quick. See if you can sort them out. And then in a second, I'll start putting them in order for you. You can pause it so that you have time. Now that you're back, let's see. 10 to the negative third again is the smallest. There's two numbers there. So we got 4 times 10 to the negative third. And then 5.2 times 10 to the negative third. And then we've got a big... Oh, wait, I missed one. 10 to the negative 12th. It almost escaped me. I almost made a mistake. All right, then, let's see. Now we have 10 to the 14th, and we have two numbers with 10 to the 14th. So 3 times 10 to the 14th is the next biggest, followed by 4.5 times 10 to the 14th. And lastly, that leaves us with this enormous number, 4.5 times 10 to the 30th power. All right, that's it.